Hello folks, we come for this problem number 5. It's just a step ahead of the earlier problem, and the earlier problem we had taken up where we had 2x squared or something like that. Now here it is 2x cubed, so 1 degree higher. Steps are going to be exactly the same as what we did before. We will take f dash x, then we'll find the critical points by making f dash x equal to 0. Then we will break it into intervals, and at each interval we will try to check how the function is behaving. So that's going to be our way of working. So let's get across doing it. As we told earlier that we'll go for the next step of derivative. Let's take the derivative. X cubed derivative 3x squared, x squared derivative 2x, x derivative 1. 7 because it's a constant, no derivative. So like that, let's get across further getting the derivatives and see how it goes. It is like 6x squared minus 6x minus 36. So that's the f dash x that we're getting. Or actually we could, if we are a little watchful, we could write it as 6 times x squared minus x minus 6 if you want. Yeah, 6 is common, so we can keep it like that. Now, as we did before, to find the critical points, because we don't know the interval, let f dash x be equal to 0, which is 6 times x squared minus x minus 6 equal to 0. 6 can go on the other side. X squared minus x minus 6 equal to 0. Minus 3 plus 2, I think would be good. So x squared minus 3x plus 2x minus 6, x times x minus 3, 2 times x minus 3. So when we break it into factors, x minus 3 and x plus 2, and that allows us to get the values of x over here. Because the product is 0, it tells us that x could be, x plus 2 could be 0, or x minus 3 could be 0, by which you get x as minus 2 and x as 3. Not like before. In the earlier case, in the previous question, we got just one critical point. So we got only 2 intervals. Now here that's on the case, you're getting 2 critical points. So you get number of intervals. Now how we'll break it into interval is, you'll imagine your real number line like this. Minus 2 is somewhere here, 3 is somewhere here. So you've got actually 3 intervals to check on. One is minus infinity to minus 2. Next interval is minus 2 to 3. Next interval is from 3 to infinity. So on all these 3 intervals, we will do the same checking as before. Those 3 interval, then sign and nature. Let's have it like that. We don't know whether it will get contained over here. Otherwise, we'll have to move that side. Interval, sign of f dash and nature. Right. So first interval is minus infinity to minus 2. You can take any point from there. What should be ideal? Minus 10 or something? Yeah, that's your wish. You can take anything. Minus infinity to minus 2. I will always go in for 10 and such things. I don't know why. So let me take f dash at minus 10. So how will it be? 6 times minus 10 squared, minus of minus 10 plus 10 minus 6. So anyhow, it's going to be 6 times 100, no? 100 plus 110 minus 6. 110 minus 6 is some positive quantity. So here it's going to be increasing. We can find the values, but basically we are only interested in knowing the signs. Next interval is from minus 2 to 3. It's very clear from here, no? Minus infinity to 2, minus 2 to 3. Now between minus 2 to 3, take any point. Between minus 2 to 3, luckily for us, 0 is there. So probably you could take 0. F dash at 0. So that is 6 times, when we could substitute 0, 0 squared minus 0 minus 6. So it's like 6 into minus 6, which is a negative quantity. Minus 36. It's a negative quantity. So there it's going to be anyhow decreasing. If we could continue this with the next interval, that is from 3 to infinity. From 3 to infinity, you could take something like 5 or 10 or something like that, any one point. If I could take f dash at 10, then it will be 6 times 10 squared minus 10 minus 6, which means it is 6 times 100 minus 16 actually. Anyhow, it's a positive quantity. Right, 10, if it is 100 minus, it's a positive quantity, that's increasing. So on this interval, it is increasing. I hope we are able to see how it is increasing, decreasing, increasing. It's alternating between those intervals. So in the first interval, it's increasing, then it is decreasing, and again it is increasing. That's it. They have asked us to do this. Check whether it is increasing and decreasing on the several intervals that they have given us. So that's about this particular question. Now we have more questions there in the next, where we have lots of polynomials. So we have to check for each polynomial. That we'll be taking that up in the next video. Thank you.